Welcome to this course on structural mechanics. In this first module, we will lay the foundation for your understanding of how structures behave under different loading conditions. You will learn how engineers model, analyze, and design structures such as trusses, beams, and frames. Structural mechanics is a branch of engineering mechanics that focuses on the analysis of structural elements, the physical components that make up buildings, bridges, towers, and other systems. This includes studying how these elements respond to forces, moments, and displacements. At its core, structural mechanics answers the question: would this structure safely carry the loads we expect it to? 2. The role of structural mechanics in engineering. Every building you see, every bridge you cross, and every stadium where people gather has been designed to safely withstand its own weight. The loads it will carry, such as furniture, machinery, or people. Environmental forces such as wind, snow, earthquakes, and temperature changes. The role of structural mechanics is to predict how these loads will affect the structure so that engineers can design it to remain safe, functional, and economical throughout its lifespan. The subject is also about modeling, simplifying real-world structures into idealized representations that are easier to analyze, yet still capture the essential behavior. 3. Classification of structures. Before diving into analysis, we must recognize different structural forms. Common types include trusses, frameworks made of straight members connected at joints, often used in bridges and roofs. Beams, horizontal or inclined members that resist bending. Frames, combinations of beams and columns that can resist bending moments and axial forces. Cables and arches, flexible or curved structures often used in suspension bridges or roof systems. These structures can further be classified as statically determinate or statically indeterminate, a distinction that affects how we approach analysis. 4. Statically determinate versus indeterminate structures. A statically determinate structure is one whose internal forces and reactions can be determined solely from equations of static equilibrium. These equations are: sum of forces in the horizontal direction equals 0. Sum of forces in the vertical direction equals 0. Sum of moments about any point equals 0. A statically indeterminate structure has more unknowns than these equations can solve, meaning additional compatibility conditions, related to deformation, are required. For example, a simple simply supported beam is determinate, while a fixed beam is indeterminate. 5. Analysis of trusses. Trusses are widely used because they efficiently carry loads through axial forces in their members. Types of trusses include Pratt truss, Howe truss, Warren truss, K-truss. Method of analysis for trusses. Method of joints focuses on the equilibrium of each joint, solving for member forces one at a time. Method of sections cuts through the truss to directly calculate forces in specific members. Graphical methods, using scale drawings, though less common today due to computational tools. Real trusses must account for self-weight of members, loads from floors or roofs, potential wind or seismic effects. 6. Analysis of beams. Beams resist bending moments and shear forces. Common beam types: simply supported beams, cantilever beams, overhanging beams, continuous beams. In structural mechanics, we analyze shear force diagrams show how internal shear varies along the beam. Bending moment diagrams show how bending moments vary along the beam's length. Understanding these diagrams helps in determining where reinforcement or greater section size is needed. 7. Analysis of frames. Frames combine axial, shear, and bending actions. They are essential in building structures where both vertical and horizontal loads must be resisted. Frames can be rigid, capable of resisting moments at joints. Pinned, allow rotation but resist translation. Rigid frame analysis requires considering bending in multiple members simultaneously. 8. Influence lines. An influence line is a graphical representation showing how a particular response in a structure, such as reaction, shear force, or bending moment, changes as a single moving load travels across the structure. Influence lines are especially important for bridge design, where loads move across spans. Understanding the worst-case loading positions. 9. Deflections in statically determinate structures. Deflection analysis ensures serviceability and user comfort. Excessive deflection can cause cracking, misalignment, or user discomfort, even if strength is adequate. Methods for calculating deflection include double integration method, integrating the bending moment equation twice. Moment area theorems is relating changes in slope and deflection to bending moments. Conjugate beam method, a theoretical transformation to solve deflection problems. Unit load method, based on virtual work principles. 10. Summary of Module 1. In this first module, we cover the fundamentals of structural mechanics and develop tools for analyzing statically determinate trusses, beams, and frames. You should now be able to classify different structures, distinguish between determinate and indeterminate systems, analyze internal forces using equilibrium methods, draw influence lines, calculate deflections in determinate structures,